Hello, young math Padawans. It's Mrs. Angel with your lesson for today on solving equations with fractions. And I know we sometimes get a little bit nervous or scared with fractions, but just remember that the same rules apply. If the equation is a sum or a difference, we're using subtracting and adding, or in the case of this video, we're looking at products and quotients, division and multiplication. So let's get started. Example 1 here, we have 2/3 of x equals 8, and this is a very typical equation you're going to see with fractions. I'm going to start as always by putting a line down the middle of my equal sign, keep the left side separate from the right. Now what's happening here is 2/3 is being multiplied by x. In other words, we would call this a product. So notice we're only going to be working with multiplying and dividing properties of equality. Step 1 is to move the multiplication into the numerator. And just as a reminder, the numerator is the top number in a fraction. So we're essentially going to take 2/3 times x and change it into multiplication in the top, division in the bottom. Well, how do we do that? Essentially what that means is we're just going to take this x and move it into the numerator. That means we're going to have a new equation, 2 times x, all divided by 3, equals 8. Now by doing that, we have now created an equation that's a quotient, meaning division is happening. And that brings us to step 2. We're going to create a big 1 out of the denominator now using EMPO. We've done this many times before. To solve an equation that has division, we are going to multiply. Now since I'm dividing by 3, that means I'm going to use EMPO with 3 and multiply 3 on both sides. 3 divided by 3 creates that big 1, and my new equation is 2x equals 24. By doing this, I have now eliminated the fraction, and I just have a very simple one-step equation left over. So step 3, we're now going to create a big 1 out of the coefficient using our division property of equality. Divide by 2, divide by 2. 2 divided by 2, as we know, is another big 1, and we're left with x equals 12. Now, of course, the last step is always the same. We need to check this in the original equation to make sure that it is the solution. To check, all we're going to do is replace x with 12 and see if it equals 8. The same rules apply as in solving. To simplify this, we're going to start by just moving the multiplication into the numerator. So that's the same as 2 times 12, all divided by 3, equals 8. 2 times 12 is 24, and 24 divided by 3, well, yeah, that's 8, which means the solution to this equation is 12. Let's look at another example. Example 2, 10 equals negative 5/3 times x. As always, I'll start by putting a line down the middle of my equal sign to keep the left separate from the right. Since the fraction in this case is on the right, we're only looking there, and we're not concerning ourselves with 10. So step 1, we're going to move that multiplication into the numerator. The negative, by the way, is going to go with it. So essentially we're moving this negative and x all into the numerator, leaving 3 as our denominator. So what does that look like? Well, our new equation will be 10 equals negative 5x all divided by 3. And now we can move on to step 2 because I've taken this equation and turned it into a quotient. Step 2, we're going to multiply both sides by the denominator to make that big 1. Since the denominator here is 3, we're going to multiply both sides by 3. 3 and 3, that makes a big 1. And my new equation is, well, 3 times 10 is 30. And on the right side I have negative 5x. Now that my fraction is gone, my quotient is gone, this is just divide and you're done. I'm going to use depot to make a big 1 factor and divide both sides by negative 5 since I'm multiplying by negative 5. Negative 5 divided by negative 5, that's just another big 1. And 30 divided by negative 5 is negative 6. Now we can move on to step 4 and check our solution. 10 equals -5/3 times -6. Just like with solving, step 1 is to move the multiplication into the numerator. So that means this is the same as 10 equals -5 times -6, all divided by 3. -5 times -6, that's +30. And 30 divided by 3 is 10, which means the solution to this equation is -6. Now it's time for you to try. On your own, try to solve this equation. -4/5 x equals -10. I'll get you started by putting a line down the middle of the equal sign. Remember, you're going to use the same steps. Move the multiplication to the numerator, apply MPO, apply DPO, and then check. Try this one on your own now. Let's see how you did. Step 1, I moved my multiplication into the numerator, making it -4x all divided by 5 equals -10. My second step was to apply MPO and multiply both sides by 5 to create that big 1. That left me with my new equation of -4x equals -50, which then I was able to apply DPO to make another big 1. Now here's where you might have gotten stuck, because 4 doesn't go into 50 evenly. If that happens, you have a couple options. Option 1, you can just leave it as a fraction. Option 2, you can leave it as a simplified fraction. Or option 3, you can convert it into a decimal. I like option 2. I'm going to simplify this fraction. First of all, I know that a negative and a negative become positive. So I know my answer is going to be a simplified fraction. And 50 and 4 have a common factor. 50 is 2 times 25, and 4 is 2 times 2. Meaning, since 2 goes into both of them evenly, I can factor 2 out, and I'm left with 25 and 2. So that means, as a simplified fraction, this would be 25 halves, or 12 and 1/2 if you were to go from there. You might be thinking though, like, how do I check this? Well, let's find out. To start my check, I'm just going to rewrite the equation, but replace x with 25 halves. You could also do this, again, with decimals and a calculator if you wanted to. Now the rules for multiplication are pretty clear. You just multiply straight across. Numerator times numerator and denominator times denominator. -4 times 25 is -100. And in the denominator, 5 times 2 is 10. Well, does -100 divided by 10 equal -10? Yes, it does, which means, believe it or not, the solution to this equation is 25 halves, or 12.5. That's it for today's lesson on solving equations with fractions. I'll see you next time.